So today's presentation content is first we introduce our research background and motivation, followed by the main composition method. It's called MIDO, Mobile Application Interface Description Language, which can apply to flow and event-based composition method. Then we present the application of our methods consisting mobile application composition, mobile mashup application composition, and tethered mashup application compositions. Before the next section, we will show our evaluation before we conclude our talk. This is the section diagram of our presentation. MIDO contains F-MIDO for flow-based composition method and E-MIDO for event-based composition method. We later show the example of mobile mashup created in flow-based and event-based composition method in this section. The next section shows the examples of tethered web services and tethered web applications which apply the flow-based composition. First, about the research background, the main drawbacks of the conventional mashup development is that the mashup are composed as desktop web applications, and that the methods do not cover the integration of mobile device functionality, such as GPS sensors, camera, or sensors such as accelerometers. And moreover, mashup cannot be developed as fast as the web-based ones are. So if you like to develop a mashup, you require to study the explicit knowledge of the device native language. So from the diagram on the right-hand side, when we look into the related work, you're able to integrate web services here, logic and data operations using BEPL. While EMML, you can integrate web applications using the web scraping technique. Furthermore, MCDL, which includes GUI elements, you can integrate GUI elements, but BEPL and EMML have high expressive power, so that the conditional statement, if else, and repetitive like loop statement are available, but it's not available in MCDL. All the approaches still lack of the capability to integrate sensors and mobile applications. So we hypothesize that none of them is capable of the integration of sensors and mobile applications if you like to integrate them into your mashup. So at this point, we would like to show the sample problem that cannot be integrated with conventional methods. So I would like to show this video footage. So this is the Nexus one. If you like to create a mashup that uses a barcode that is available on the device to read a barcode number, and then you use the barcode number to query to question something, to search something from Amazon.com. So the number will appear here. And later, you use this book title to search for another information from goodreads.com for the book descriptions and reviews. So after everything is finished, the mashup, you would like the mashup to summarize all the details of what you have into this page. So, so the question is, when a user wanted to create a custom application that interprets the book barcode into book name, and later interpret the book name to search for book descriptions, reviews, and later you would like to display the summary in the form of integrated information in the last page. So the user is required to perform to one, access the functionality of mobile phones or the camera or that barcode reader, and integrate the data with web-enabled resources, Amazon.com, goodies.com. So users are required to fulfill their skills, including GUI design, coding, and data flow management. So the conventional method provides only the solution to integrate web services using XML HTTP request, or web scraping or web extraction used via a proxy web server. And sometimes the GPS location-based information is also available if you integrate everything using the web markup language. Somehow this component is not available when you integrate things in web markup language, something like the camera-based applications, barcode readers, voice recognition, text to voice, personal database on the mobile device, or sensor including accelerometer or gyrometer. So in the next section, we state our motivation in conducting our research. Our goal is to, one, explore a mobile mashup composition model so that we study the data models, mashup languages, and evaluate them with our approach. Number two, we would like to enable the mobile mashup development and end-user skill fulfillment so that we approach an end-user-centric mashup development using an XML description language. It's called MIDL, Mobile Application Interface Description Language. Our target is that we target composer into two groups. We hypothesize that novice composer can use common web pages, and expert composer can use do programming. So the fundamental model applies the flow formalism to deliver uses of web applications, web services, mobile applications, to create first mobile mashup applications and separate mashup applications. And we also target the device-dependent deployment so that the sensors and the mobile applications available on the device can be integrable. We would like to fulfill the incapabilities of this device-independent approach. Device-independent approaches require a proxy server to be able to integrate the components and run the mashup. So for Yahoo Bytes for iOS device, only the integration of web services and logical operation are available. So you can have the output as web applications on proxy servers. The drawback is that the integrable component is limited set of web service. Our language called Maria. You can integrate web services, logical operations, and GUI elements. So the output is also integrated as web applications on proxy servers. It also includes dynamic graphic display elements, but the drawback is that it uses the proxy servers architecture so that the device sensors are not integrable. And of course, no research presents a mashup model and a method for multiple device usage scenarios. So we are going to present the multiple device usage scenarios later in our presentation. So before we go through our presentation, we would like to define two main keywords in our research. The mobile mashup application is a mobile application created from an integration of components. The application is used locally on the device. Number two, tethered mashup application is a web service or a web application created from an integration of components. So the application is used locally on the device or remotely accessed from tethered or connected devices. So the device will function as a mobile server in this context. So about the tethered mashup applications, it enables the platform-independent communication between devices for interactive collaboration and functionality exchanges. It also enables event-based mashup compositions so that you use HTML and apply the tethered web service method as an extension to reuse